Okay, so exam 3. To get rid of these radicals and solve these radical equations, you have to square both sides or cube both sides. The big thing that you have to be careful of in squaring both sides is in the third part of this problem, and that is when you square the right-hand side here, when you square x plus 1, you can't just square it out and get x squared plus 1. You have to FOIL that out, and you're going to get x squared plus 2x plus 1. From there, you need to set one side equal to 0. So I subtracted 3x and subtracted 7 from both sides. You got a quadratic equation which factored. In these types of problems, they're long enough that if I gave you something like this, I'd make sure that it factored easily. You will not have to use a quadratic formula there. Now, one of these solutions didn't check out. It was an extraneous solution. If you tried putting in a -2 there, it wouldn't work. So be on the lookout for that. You have to check your answers in these types of problems. Can you name any famous mathematicians other than Jeff Parent? That's a good answer, but any famous. There's one mathematician whose name and whose work we used. Pythagoras, yeah, Pythagorean theorem. There you go. So make sure you know the Pythagorean theorem. A nice, quick, easy problem. From the Pythagorean theorem, you can actually derive the distance formula. Now, there's 3 formulas that kind of all are very, very similar. There's the distance formula right here. There's the midpoint formula. And there's one more that's kind of similar to this. They all involve x1, y1, x2, y2, and that's the slope of a line. So that's m equals y2 minus y1 over x2 minus x1. So make sure you have all those memorized and you can keep them straight. Don't mix them up. Speaking of formulas, one that you certainly have to have memorized, I don't know as though I'll ask it, but if I do, that's free points, is the quadratic formula. You will not finish this test without using the quadratic formula. That's a promise. Sun rises in the east, quadratic equation will be on the exam, period. So make sure you have it memorized correctly. All right, so a couple examples using the quadratic formula. Like I said, you expect one to involve the quadratic formula. This one involved I as well as the quadratic formula. Completing the square was quite a big part of what we did in this course. We use it to solve these types of problems. We put circles in the right form by completing the square. We did the same thing with ellipses. You could do the same thing with hyperbolas. We did that with parabolas. So completing the square is something you should definitely know. Add, subtract, multiply, and divide complex numbers. And some more quadratic equations, in this case the square root property. So make sure that you use the square root property when you can. It's the easier way to solve this thing. All right. Checking the sound, recording devices. All right, we still have sound. That's good. All right, let's move on to exam 4. Some work with parabolas. You should be able to spot the vertex and give me the equation of the axis of symmetry. Now on the final exam, I'll probably write equation in bold and italics because a lot of times people will give me just 2. I want a little bit more than 2. I want x equal 2 or y equals 2. X equal 2, what kind of a line is that? Is it vertical or horizontal? X equal 2 would be a vertical line. Y equal 2 is a horizontal line. So make sure you know those. Here's completing the square again. In this case, it's to put this parabola in this standard form. Now the math department in its wisdom has come up with a bunch of core course outcomes. I'll mention these when we discuss the final exam review that's online. But one of them is to solve nonlinear inequalities and represent solutions with interval notation. 2 out of 8 of these have to be present on your final exam in a rotating basis. So in this case, here's a couple quadratic inequalities. Or this is a quadratic inequality, this is a rational inequality. Make sure that you can solve these, and your answers should be in interval form. So that's exactly what you have on problems 3 and 4. Solutions in interval form. Let's see. Let's do these in order. So problem 5 is probably why I let you guys rework this test. I decided, you know what, enough of you got it wrong, that maybe it was my fault or something like that. I'm not sure what made this problem so difficult for you guys, but make sure you studied it on your final exam or in getting ready for your final exam. Be ready for. I didn't think these were hard problems. Maybe I didn't do a good job covering it. Not sure, but spend some time on those. And with inverses. Man, we covered a lot of stuff, right? Wow. What's the relationship between the graph of a function and the graph of its inverse? A little bit more than opposite. They're mirror images around the line y equals x. So take your graph and flip it over that line, y equals x, and then you have the function, and then its inverse. So that's what they should look like. Logarithmic equations and exponential equations. So on this page we had some logarithmic equations. One way to solve logarithmic equations is to rewrite these. Remember, you write the base to this equals this. So 8 to the 2 power equals x. You do the same thing with this one, the same thing with this one. The only difference is with these two logarithmic equations, the base isn't written. What's understood to be the base when you just write log? 10. What's understood to be the base when you have ln e? So if you can write those like that, then it's just the base to that power equals this. E to this equals x. So a little bit more than e. No, did not. Some more problems with shifting. So shift to the left by 2, shift to the right by 2, shift to the right by 3, and down 2. So a couple of different problems with shifting. And I think there should be one more page here. I feel like I'm missing a page on this one because I think there was some... No, you know what? It's in the next exam. So that's exam 4. Done with that one. All right, exam 5. Time to do a sound check. Recording devices. Oh, we still have sound. That's good. Okay. I guess I can get rid of you. Some more work with logarithms. You'll be given the change of base formula on the exam. In fact, I'll point out in the review where that is. Let's see. Properties of logs. Expand things with logs. Contract things with logs. nobody on the last exam wrote "ha here." Logbook? Yeah, I thought that was clever. Come on. They actually used to use logbooks. It's a historical thing. Before ships could really navigate effectively, before they had chronometers and could understand where their longitude was, what they used to do is kind of estimate where they were using a little distance equals rate times time problem. They would literally throw a log overboard and watch it float by, and they would time it and figure out how long it would take that log to go by, and then they could figure out how fast they were traveling. And they would write these things down. And of course, where did they write it down? In the log book. So, all right. Ha, it's ha squared or ha. Oh, that's my own. That's my editorial comment. I'm laughing at my own joke.
Oh, okay.
All right. So yeah, you're right. It's not part of the problem. All right, but thank you. Let's see here. We solved exponential equations, and in this one there's really two ways to solve it. Although in class we pretty much discussed taking logs of both sides. So that's how I solved it here. I think I gave you credit. If you didn't realize and crunch the number, if you left it like this, I gave you credit. It did turn out to be negative 3/4 though. Okay, so some more exponential equations. These are a little bit more challenging, but I only had you do 2 out of the 3 there. So that was kind of my way of being fair about these things. And the same thing with your logarithmic equations. Now with your logarithmic equations, we did discuss 2 different ways to solve these. The first one we've already seen, that is to take the base to that power equals this. So you rewrite it using an exponential, and then you can solve there. The other way is if you have the log of something equals the log of something else. And if that's the case, you can kind of get rid of the logs. Now it would look like this on your paper. You'd go from here down to here. That's what I expect for most of you. For those of you who want that extra point of credit, some extra credit, this is the step that you actually use to try and finish this off. That is 10 to the log base 10 of this, 10 to the log base 10. These cancel each other out because the exponential function and the logarithmic function are opposite of each other. In fact, that was the point of a couple of the problems early on the test. Right on the first page, log base 4 of 4 to the 7. Those cancel each other out. You get 7. 5 to the log base 5 of 10, again, cancel each other out. You get 10. So those are only worth 1 point each in case you're bummed that you didn't get them. Don't stress about it. From there, after logarithms, mercifully, we went on to something a little bit easier, which was systems of equations. You could solve those by substitution. You could solve them by addition. Make sure you know the terms of consistent and inconsistent, dependent and independent. Based on the graph here, the 2 lines are different, so that means that they're independent. They don't cross each other. Therefore, there's no solution, so it's inconsistent. No solution. We moved on from that, made those problems a little bit more challenging, started dealing with 3x3 systems of equations. It's probably a good bet to expect a 3x3 on the exam, although I did give you the option on one problem of solving 3x3s with Cramer's rule. I give you a little bit of help to do that. I would not do anything with Cramer's rule harder than this. In general, I don't recommend Cramer's rule as a way to solve a 3x3 system of equations. Let's see. I think that's about it for this exam. We've covered a little bit of stuff beyond exam 5. We've graphed hyperbolas, ellipses, and parabolas that open sideways. So, in looking at your final exam review online, you should see some of that stuff there. There is a problem or two that I think I might delete as we go through this. So, keep an eye on that part. This should be part of your studying, not all of it. But certainly one of the things you'll see when you pull up this file online is that I've highlighted some of the problems in bold and red. So it doesn't print out that way, but it is in terms of red. But this is one of the problems that you should be ready for. We did a lot of factorization. So factor these things as much as possible. So I can see a bunch of it there. The first one is factor by grouping. The second one is the difference of squares, but you get that difference of squares twice. So a little bit more than just a regular difference of squares. Greatest common factor, trinomials in the not so nice case. Difference of cubes. Definitely worth some extra study on that one. Problem number 8. We didn't do as much with lines as I'm used to in this course. That's a reflection of the new book. So I'd probably say, yeah, don't really have to worry about problem number 8. But just in case you're curious, parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals. So -8 and 1/8 respectively. We did do synthetic division, right? I think I just left it off of one of your early exams. I think I just forgot. But we did do synthetic division. More work with shifting. That one starred. Again, more work with shifting. Some work with square roots, distance. Pythagorean theorem could be an easy one. This one. When people solve this, like I said even before, just today, the biggest thing is to square this out and not get r squared plus 81. What you want to do is you want to multiply that out. You get r squared minus 9r minus 9r again for a total of 18r. And then from there, you can move on, subtract 2r from both sides, and add 3. R squared minus 20r plus 84 equals 0. I think that's going to factor as, what, r minus 14 times r minus 6. Of course, if you're really stuck, you can use a quadratic formula. If you check these solutions, r equals 14 will work, r equals 6 will not work. Checking back in here, 6 minus 9 is -3, and that's not equal to the square root of 9. So you have to throw that one out. I can't recall. Did we do some of these problems like this with substitution, where we did a little u substitution to solve here? I'll have to check into that. But we certainly did problems like this. Polynomial inequalities, rational inequalities, and answer in an interval along the x-axis. So this is the ones where you test your, you figure out where this is equal to 0. This should be a 5. X equal -5, x equal 4. And then you test points. Positive, negative, positive, etc. So in this case, you want the positive intervals from -infinity to -5, union 4 to infinity. Now, a couple of these I've put in bold. This one is in bold on steroids. Enough said about that one. Parabolas, make sure you can work with those things. here's kind of a revisit to that problem on your fourth test that you were able to redo. So make sure you can work with those. Interest problems, probably a good idea to be ready for those. Here's your change of base formula. I will give you that on the final exam. You should be able to use it. Now you don't need to use it here. What power of 4 gives you 64? 4 to the third. What power of 6 gives you 1 over 6? -1. This one, take out your calculator and just do ln of 37. This one is just a regular log of 37. So you have keys for that one. This is the only one for which you would actually need to use that formula. Log of 37 divided by log of 17. Make sure you round your answers according to what the problem asks. Alright, a lot of this is stuff that I have gone over. There is one problem that, well, actually there's a few problems I should mention. Stuff that we've covered past our last exam would be graphing circles. This is the graph of a parabola that faces to the right, so be careful with that one. This one was exactly on your handout from section 13.2, so you might want to go back and look at that one. Problem 61b and problem 62. Which one of these is a hyperbola? Which one of them is an ellipse? So, how can you tell? All right. I think you're right. You said the bottom one's a hyperbola. There's a subtraction there. That's a hyperbola. Well, it's in the proper form for the equation of ellipse. So if you have a plus here and you have a couple squared terms, then this one's going to be an ellipse. So let me just take a quick look here for you. If I had x squared over 3 squared plus, oops, thank you. X plus 2 squared over 3 squared plus y plus 1 squared over 3 squared. If these two were the same, then this would be a circle, if those two denominators are the same. Now, the two denominators are the same would be the same as having, for instance, x plus 2 squared plus y plus 1 squared equals 9. So if I multiply both sides of this equation by 9, both of these would cancel. And you see that you have the same coefficient of a 1 for your x squared and your y squared. That's not going to be true if these two things are different. So, all right, make sure that you understand the difference between an ellipse and a hyperbola. There's not much I can do if you're drawing an ellipse and you're supposed to draw a hyperbola. This one's already solved for. So what you could do would be to start out with the center. The point at the center is 1 and -1, so 1 and -1 would be down here. Then you want to move 3 to the right, 1, 2, 3, 3 to the left, 1, 2, 3. A lot of times people forget to count the axes for whatever reason. In the y direction, I got to move up 2 and down 2, 1, 2. And then I'm going to draw that box. So that rectangle. So here, 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 and here. Then I want to draw the diagonals of that rectangle. So here. Now, very importantly, because this is worth probably 2 points out of maybe 7, is that your hyperbola opens the right direction. Which direction is this going to open? Left and right or up and down? Left and right, because you have a squared term that's your x is a squared term, so something like this. Okay, and make sure that your hyperbola gets close to the asymptotes. It's not going to touch it, but it should get close to those asymptotes. Yes? Well, there's, boy, it's a good question. The inverse of this would be a big mess, but it would probably be some other type of hyperbola. Yeah. Correct. Correct. It's not going to be up and down. So, all right, one last thing to mention here, and that's with regard to problem 69. So, moving a little ways back here. Problem 69 reflects stuff that is no longer part of this course. It was called linear programming problems. So, you can scratch that one all together. Okay, good luck. See ya.